and say thank you and welcome, and thank you for joining us for an hour of information about compost and soil health. Oh shoot, sorry, I'm having a couple issues. There we go, I'm good now. Yes, okay, so before we get started, I wanted to do a little bit of housekeeping. Oops, hold on. You know, I do this every day and you would think I'd be more facile at it. Okay, so here we go. So yeah, it's kind of funny that I'm saying this now. A few tips for your best experience. Joining with computer audio if you can is recommended over the phone. If you can't hear, sometimes this happens, it turns out your volume isn't on. And then so you can get the most out of Ron's slides, make sure you have Zoom in full screen mode. Today we won't be using the chat. I'm sure a lot of you are familiar with that. We will be using the Q&A box, and that is either at the top or the bottom of your screen, depending on how it's set up. And go ahead and type a question in there, and then we will address those at the end. We are recording this, so if you want to come back and look at it later, that might be a possibility. I don't want to commit to making it available until we look at it and make sure it's a good quality recording. And then lastly, we will be asking for your thoughts and feedback at the end. And how we're going to do that is when you leave, you will be automatically directed to a SurveyMonkey evaluation. But to do that, it turns out you actually have to click leave meeting in the bottom corner of your screen. And then you can go ahead and do that. And if you miss that opportunity, we'll be sending out a follow-up email tomorrow, and you will have that link there as well. So Stop Waste, we are hosting today, and I also want to acknowledge our fellow sponsors, Zanker Recycling / ZVest, Composting, City of San Jose, and Republic, and also our partners in putting this event together, ASLA Northern California and CLCA. So thanks, it's been fun working with all of them. Okay, so Ron, I know many of you are already familiar with Ron and maybe have had him come talk to your office before. But Ron is unique in that he is not only a compost expert, but also has an extensive background in horticulture. And he does talks all over the country. He does them all over the world. He provides technical assistance to landscape architects, to composters, is really a unicorn in the composting world. And it's my great pleasure to have worked with him for the last several years. So with that, I will go ahead and turn it over to you, Ron, and we can get started.
Well, thank you very much. Let me hit where's my share screen? All right. I hope everybody likes my virtual background. I picked it just for you all, and I'm kind of looking forward to getting back to the West Coast. But I am also going to turn off my camera while I'm speaking. Is everything still okay? Do you still see the presentation, Kel?
Oh, yes.
Okay, so everything's good. Okay, well, thank you everybody for being here. It's always fun to talk to people in California. I'm in North Carolina, as many of you know. I do work all over the country. It's very weird at this time with COVID. Every state I work in is a little bit different, and some people are locked in, and believe it or not, I got clients here in North Carolina. Their landscaping is still allowable here, and so who knows where this is all going, but compost will fix all. Remember that. Stay positive. So here are the topics for today. You know, why is compost becoming so popular? Benefits, composting and feedstocks, and then specifying it. And this is what I want to take some of the discussion to a different level on teaching people, showing people how best to specify the product. Now, people will sometimes ask, why is the product becoming so popular? Why is it specified so often? And if you ask me, I would of course tell you give you an obnoxious answer and tell you it's just the greatest thing since sliced bread. But the product is actually incredibly efficacious. The product works really, really well. We'll discuss some of the benefits a little bit later. It's also really the most inexpensive form of a stabilized organic matter source that's available to the landscaping industry that has really unique benefits. And of course, today, one of the reasons you're going to see it in more and more specs, or you're going to be landscape architects, you're going to be required to specify it, is because of environmental regulation coming. We're making more compost and more recycled mulches, and it's actually going to be required for use. So here's the product. Here's the product we always talk about. Unique product that it goes through 2 temperature phases, a high temperature phase and a lower temperature phase. The lower temperature phase, obviously, what goes along with that lower temperature phase is a stabilization of the carbon, which is very, very important for landscape applications. But why is it becoming more and more important to use compost? Well, because there are things that are going on around us that we can't really control, and creating soils that are more resilient will help us dealing with the threat of climate change and also the droughts that are coming along with them, and they're becoming more frequent and they're becoming longer in duration, right? Of course, we also have a situation, oh, I'm missing something there, also that we have regulation that's come about in the state, 1383, which is going to require more recycling of organic materials, which means there's going to be more compost being produced. That is, for this, one of the greatest reasons for that is so there's less methane created by having organic substances go into the landfill. And the other thing that's important to know is that along with some of these regulations, like 1383, there are going to be procurement requirements coming along. Some of the things that are in place right now, a lot of people have come to MWELO events that they've seen me and Kelly and a whole host of others do, but this is already in effect in most of the state, where if you create a new landscape, you have to have a water budget, and it is suggested, it is required that you add compost, unless you have 6% organic matter, and add mulch. And obviously this is all about saving water. There are other initiatives going on in the state. There's actually a soil health initiative in the state for agriculture, which is kind of cool. Not hugely funded at this point, but it's all about improving soil and building adequate organic matter that can help in carbon sequestration and reduction of greenhouse emissions, of course. And there's a lot of reasons why soil and soil organic matter impact the climate, and why soil is actually a really integral part of managing climate change, or making us cope with it. And again, it's going back to making soils more resilient. Getting organic matter in the soil, creating healthy soils improves, plant health and yield, increases water retention and infiltration, which does lead to improved water quality. And of course, we help to reduce erosion and sediment movement. We sequester carbon, and we create better diversity of habitat for wildlife. This is important in ag. It's also important in landscaping, and a lot of the requirements or the benefits cross over. I did want to remind everybody to let you all know, you live in California. So on top of everything else, you live in a state that what all the research shows us is that if you live in a region of the world that has high average temperatures and low rainfall, you mineralize carbon that much faster. So you guys, on top of everything else, you basically lose carbon faster into the atmosphere, right? So always remember, and we talk about soil health, organic matter is a key component to healthy soils. And here's a very, very complex graphic that just talks about, you know, the improvement of stormwater management while improving soil. There are so many other benefits, and one of the things that really concerns me, having worked a lot in erosion control and stormwater management, is stormwater management is one of these kind of financially backbreaking things that will come out of climate change, things that cities will have to deal with. And what it means is that there is going to be more emphasis in improving soils, make them more absorptive. And that's why we have to look at not only amending soils with compost, but also replacing landscape soils. And why? Why do we do this? Well, operationally, there are some very specific reasons, like the fact people have seen this slide before. We typically go onto job sites where we have damaged and depleted soils. We're not getting true topsoil, right? We have low organic matter, fine, in the Bay Area, a lot of fine soils that compact very, very easily. So when the rains come, they don't like to perk. They don't like to accept water. And of course, also in normal land construction projects, the top layer of soil is typically removed. Many times it's sold or removed off of the site, and we don't really know what comes back to the site. You know, you hope you get good soil coming back, and landscape architects out there, you guys can require that by just simply, you know, requiring any soil that comes back have a higher organic matter content. And the whole goal here, of course, is to reestablish that carbon cycle. This is the importance. This is something that I like to talk about because I have very little going on in my life, apparently. But no, it's actually a better understanding over the past 20 or 30 years when we talk about soil organic matter. It's not a static thing. It's a cyclical thing that changes, and it starts with living biomass that dies off, becomes an active fraction of organic matter, which means microbes are really going after it to degrade it. That causes certain benefits to the soil and to the plants. And then as that organic matter stabilizes, it becomes more of a passive fraction, which also helps the soil, but in a different way. The goal would be is if we maintain the site and we build up some passive organic matter, it will lead to more living biomass and for the cycle to continue and recreate organic matter as we go. But the key aspect here is all organic matter is not the same. But it does. Nice stabilized organic matter provides lots and lots of benefits to landscapers. I won't go into great detail with this list. I'll just focus on some of the most important things for the Bay Area. Number one is the improvement of soil structure, soil aggregation, you know, having biologic glues stick little particles together to create larger pore spaces to help roots shoot down and get better, deeper rooting faster. And just helping to keep these water stable aggregates going, which will keep large pore spaces open to accept more water. Key aspect, right? Of course, improvement of soil water holding capacity. I throw this number around a lot. For every 1% organic matter we increase over an acre of soil, we hold an extra 16,000 to 20,000 gallons of water. So we all sometimes have this concept of strive for 5% organic matter in landscape soils, and we'll end up creating a soil that'll hold an extra 80 to 100,000 gallons of water, which means a reduction in irrigation. And this is just an interesting a research that I was involved with over 10 years ago now, but it basically shows how the addition of organic matter in 10, 20 to 30% inclusion rates, that means by volume, increase organic matter content, increase or reduce bulk density, and then also improve water holding capacity. And these are all characteristics that are very, very intuitive. We would expect these to occur, but of course, this idea of increased percolation rate, which is this test saturated hydraulic conductivity, we also improve percolation rate. And that is something that we've documented over the years. There are stormwater best management practices now in place all over the country for the use of compost, because this has been documented and we can improve the soil. The cool part about this is thinking about climate change and the effects. Well, if we improve the soil from the start, get that carbon cycle going, we hold water when there's droughts, and we accept more water and move it along when we get more water. So this is really, really key, I think, to creating that more resilient soil. Of course, adding this nice stabilized carbon to the soil also helps feed soil microbes. We also bring soil microbes in with us. These soil microbes do a lot of things. While they try to decompose the organic matter, they cycle plant nutrients. They also help in disease suppression. And remember that the microbes live on plant roots and actually work as a extension to root hairs, helping the plants absorb water and nutrients that much easier. And this is something near and dear to Kelly's heart, and that is she has sponsored some work to do another version of the marine carbon project, or create another data point. Basically, this is research that's really starting out in California, showing small amounts of organic matter, of stabilized organic matter on the rangelands, look to have a long-term climate change effect. We won't get into that right now, but take a look over here to the left where the compost was added. For some reason, those cows are over there more than in the other area. Pretty cool stuff. We see this, I've seen this elsewhere across the country. So compost is this crazy product. When I first started with it in 1984, it was really kind of an unknown material, but it's a tool. It's a tool for the landscaping industry. It's a tool for landscape architects to help basically remanufacture or reclaim poor soils. Compost is made at different scale and sizes. As you can see here on the screen, the key aspect is pampering the microbes, giving them the oxygen and the food and the water they need. And the process typically takes somewhere between 4 and 6 months, but it's highly variable, really. And here's a good overview of a facility. It's a surface area phenomenon, which means it helps the microbes when we grind the material and make the sizes of the material they have to basically digest or consume smaller. We turn the windrows to refluff it and aerate the piles. We used to always say it's to aerate, but really it's for fluffing the material to help in convection. We have this wonderful high temperature phase. Remember, the magic number is 131 degrees Fahrenheit or 55 degrees C for anywhere between 3 and 13 days, depending on the technology. And at that time and temperature, there's a time and temperature relationship that takes care of plant pathogens and weed seeds and even human pathogens, okay? High temperature phase, then we have a lower temperature phase. Temperatures start dropping. Remember, the composting pile reduces in size to roughly half. And once the temperatures start dropping, and if you notice in this cool little graph down here in the bottom, the oxygen demand is real high in the beginning and it gets lower and lower because there's less food for the microbes. So temperatures drop and therefore there's less oxygen demand and the CO2 being generated through the consumption of carbon. And then we screen it and we make this lovely product that everybody's got in their hands as we speak. Typically 3/8 inch screen minus is industry standard. In your neck of the woods, your primary compost in big volumes of compost are going to be yard trimming based and food residual based. Sometimes you'll see the term SSO, source separated organics. But there will be other materials like biosolids and some agricultural materials and maybe even some industrial materials. Remember, when you hear industrial materials, don't get too excited. Don't be too upset, because I have clients who take vegetable waste from a baby food factory, and that's their industrial. Doesn't necessarily mean it's dirty, right? Remember this though: the feedstocks that go into the product affect the characteristics of the finished product, and we'll talk about this in a little bit of detail, because I don't talk about it much, and this has a lot to do with specification and choosing your product. Probably the biggest effects to the feedstocks of the compost are things like nutrient content, which also relates to electrical conductivity or soluble salt content, whichever term you like to use, and pH. Okay, now what do you want to know about the actual feedstocks? There are some things here I wanted to put on paper. The characteristics of the different feedstocks compost. Biosolids, beautiful product, of course has a ick factor that comes along with it, cannot be organically listed. The material can be higher in nitrogen and higher, some of the materials are higher in ammonia, which also can lead to higher soluble salts. Yard trimmings compost is the most highly available material probably in the state. It's going to have a lower nutrient content and salt content, and it will be organically certifiable, whether that's done through OMRI or through the CDFA. The same that can be said with food waste and yard trimming compost mixes. That's also a huge volumes in the Bay Area, and actually the biggest composters in the area are making yard trimming and source separated organics compost. I rate it's highly variable, and what I mean by that is the more food waste you have in the material, the more it impacts nutrient content and sometimes salt content. So that material is could be a little bit more variable based on how much food waste we have in the mix. Of course, that material also can be organically certified. We have to be cautious, of course, that we have found that with more food waste going into compost, that we're getting more man-made inerts in there. So the composting industry always tries to be vigilant in dealing with that. And of course, we have manure-based compost. It's really less available in your area, and it's higher cost. It's typically low in inerts. Often it gets very fine and high bulk density, but it also has a high nutrient content, can have a high soluble salt content also. And it is also OMRI listable. So I hope that's helpful. And just adding on to that, I just want to show you here, by the way, there's a picture to me of the left. I'm actually planting a tree. My wife and I did that after 2 weeks of lockdown. And I just want to prove to everybody that I'm not quite as lazy as I make myself out to be. I'm actually planting a tree there. But let me just make a point. Tree planting, shrub planting compost. You want very good compost in this application. Very stable and mature. Okay? Very, very important. Over here in the middle, this is like a native planting. With native plantings, I like to see compost used that have low nitrogen content. And really, when I say low nitrogen content, it's or really high in organic nitrogen. So it's low in ammonia. So basically the nitrogen is there, but it's very slow release. We don't want to flood the soil with a lot of nitrogen for native plantings, and we want that to also be stable, right? Down here, the bottom left, this is a little rain garden, but you could say the same thing about bioretention soils. We want product that has lower nutrient content, that's very, very stable. And also, I think going into the future, we're going to start talking about, we started testing compost for humic acid, humic substance content. And we find the better we compost, the more humic substances, the higher the cation exchange capacity, which actually would make that a more valuable product to put in a stormwater media, because we want that to be scrubbing out or pulling out heavy metals. So that's something that we could talk about later on potentially. Over here at the bottom right, we have erosion control compost. There's some research that was done in Caltrans. By the way, if you look at the top of the slope, we have a compost blanket and berms. They're working very well, and the stuff down below basically blew off the slope. The hydro seed blew off the slope and failed. So we need coarser compost for that material. We don't want to have inert content in that. It would look ugly on the roadside, and we have to have product that meets the proper size, particle size distribution for erosion control compost. And then I slid here into the bottom right a little picture of a bioretention mulch. People who are working with bioretention mixes, we are finding that we can make really good bioretention soil mulch with compost overs. That is probably a discussion for another time, but we can deal with it in Q&A also. Okay, so purchasing and specifying compost. There are some, not secrets, but there are things to know when we're looking to buy compost and to more easily specify it. So it is important to know. I have a friend of mine in the industry, a friend of Kelly's, that every other year or so we're tracking how much organics are being recycled regionally, and in the Bay Area, or the extended Bay Area is what's called. There's plenty of organic waste, organic byproducts being recycled. Back in these figures in this report that was done in 2019, there was about 2.5 million tons of material being recycled. And if you look at the bottom, about 40% of that was made into compost. And look at the bottom, a lot of it went to boiler, a bunch of it went to boiler fuel and to alternative daily cover, where they use it to cover up the landfills. And those uses are going to go away. So we're going to see much more compost and mulch being produced. And roughly for every ton of waste, organic material, leaves, brush, you make roughly a cubic yard of compost if you go that route. So we have plenty coming, plenty's already available. And next steps, you're choosing your compost product. So there are things to consider for landscapers and landscape architects. Landscape architects, in your bid documents, you're always going to ask for samples up front. Lots of times we ask for quart samples. That's a little bit cheesy. I think we probably need to be offering a gallon. If it's a coarse compost we need a sample of, you probably need 2 to 3 gallons to look at, especially if you're going to send them off for your own testing. You need a few gallons of that material. But getting a little bit larger sample in your hand, I think, is a very, very good idea. Getting your compost technical data sheet so you can look up what the characteristics are of the product. That's an important thing. And then it is really important as you specify the product. I know I deal with landscape architects in the area, and it's really cool. The landscape architects getting smarter and smarter, more experience with compost. So the things that they need to know are much more in the minutia side of things now. Really, really cool, specific things. But the more you play with the stuff, the better you learn how to interpret the test data. Now, I will tell you that right below this, I'm pointing out right now, this is an updated, it's basically a document that helps you understand why we test for the certain tests in the SDA program, and explains what it means, what their importance is to soil and to plants. And then off to the right here, I have an updated document that's gone for its 3rd gyration now. It was first developed in 1996, believe it or not. That's when I still had sanity and hair and patience. And this has been updated. We modified some of the spec numbers and some other things to talk a little bit about natives. But basically, this is a spec document. I'll talk to you a little bit more about that. That will also help you understand the application that much better. Within the spec document, there are 6 different end uses outlined. As you can see here, 4 of them are for landscaping, 2 are for erosion. They're thrown in there because I wrote the national standards for that, and it was easy to add in there. I know that you guys don't always deal with the erosion side of the world. And the specs kind of, here's what they outline. They give in a description of the work. They discuss what the material is. Over here, there's actually a numerical standards for the different applications. You could pop these out and put these right in your specification document. I help people do that all the time. And then there, of course, there are steps to explain on how to use the material. And this is kind of the format. It's typically a 2-page format for the spec, talking about the materials to different levels, and then how you incorporate the material into the spec. Know that when you're looking for a compost, there are things to look for. I think we should start specifying composts that are certified. I try to, when I work with landscape architects, insist that they specify STA certified composts. They're tested on an ongoing basis. There's some third-party monitoring going on, and it allows the people who are specifying the product to go to several potential end users and get data and compare it in the same format. It's a beautiful thing. I'll talk a little bit more about that later. And then sometimes people want to specify that the product be organically certified, whether through the California program or the national program. Remember, you can't call yourself organic in California without being approved by the CDFA. So even if you have a product that's OMRI listed nationally, they actually have to register the product through California, through the CDFA, that's easy for you to say, through the CDFA's Organic Input Materials Program, and kind of get it certified again. I really encourage people who have nothing better to do in their life. That's a joke. But if you use compost a lot, see if you can get a tour of a composting facility on downtime. It's actually kind of fun. I will tell you though, don't be obnoxious if you go out to a site, because you could be buried and there won't be any DNA of you left in about 3 months. Okay, so you get buried. But it's a fun thing to go to and get tours. Sometimes I do training events for landscape architect groups, and we do it at a composting site, and we actually do a tour, and people really, really enjoy it. They really, really do. And then remember, for people who are there, if there are landscapers here on the site, or if there are landscape architects who are being paid extra to help manage the actual landscaping project, you know, it's always nice to have them to open gates for the first load of compost, inspect it before it's dumped. That's a good thing. And then for people who are specifying the use of product, remember, if you're specifying an inch of compost, that's 134 cubic yards. That's typically 3 truckloads of compost, and you should have 3 bills of lading saying, you know, 50 cubic yards or 45 cubic yards to meet that requirement. So that's one of the things you can do to make sure enough compost is being brought to the site. Also, there are some great tools thanks to some work that Kelly has done with Wheelo, but also for Kelly, what do we call it here?
The lawn to garden website?
Lawn conversion. I just had one of those brain things. But anyway, there's a website that landscapers and landscape architects can go to when they're looking for compost. That's the Lawn to Garden website. This is a kind of a neat website because it has a search function, and it'll list out manufacturers and distributors just in case you have a small job. Of course, you can go to the SDA's website to verify that composters are still in the program. If they get themselves in trouble, become naughty, they get pulled off the website if they get suspended. But you can make a few little clicks, find compost, select the state, and then there's a list of people in California, and you can scroll down and you can find the composter in your area. Okay, so that's looking for compost. It's not hard to find compost. Sometimes it's hard to find what you're looking for, but I think the more you know where to look, the better you are there. But here's a good example of specification of compost, and it's a little bit of a pet peeve of mine because, and I understand why we have it. So here's a little section, a organic material section that a landscape architect may use in their spec, and it gives the landscaper a choice what to use for a particular project. What I suggest landscape architects to do, if you have an understanding or a belief, a desire of the product you want to use, then I think you should go through and basically take some of the choices out of there. Like for instance, peat moss. Unless you're growing acid-loving plants, I don't use peat moss anymore. If you're trying to keep the pH down, well, one of the things you can do is blend compost with softwood bark 50-50, and it'll have a lower pH. Okay, but you can take some of those other things out of there. Things like there are more people that are getting away from specifying nitrolyzed sawdust, and you could take that out of there. But the point is that this is a really important section. Hone it for your project, and also really be aware if you're naming composters who are the 2 or 3 composters in there that can supply for your project. Understand, I've looked at specs that the facility was bought twice over and the name of the product has been long gone. So we need to keep the name of the company or the facility and the products up to date. And if I'm asked to review your product, I will help you, your specs, excuse me, I will help you do that. Okay. So what else do you want to have inclusion within your specification package? You know, you're going to mention compost in the definition sections, within the submittal and quality assurance sections, and of course the product description to at least, right? I also want to mention, and I'll show you some examples of some of the text, which I will put in a document and made available so you can cut and paste it. So you have standard documentation there, or verbiage. But also remember, one of the things I always look at when I'm working with landscape architects and reviewing their specs is understand sometimes there is a lab listed within the spec and says, send your sample of soil, send your sample of compost and send it off to this lab. Well, one of the problems we have is lots of times the labs that are good at testing compost are not good at testing soil, and vice versa. So one of the things that I do when I look at specs, spec language for landscape architects is I make sure that the correct labs are put in there. And often it's more than one lab you're going to list. You're going to list one under the soil section and probably one under the compost section. And of course, we're going to test the product, and we want to test it to make sure that we're producing this type of product. But this is the definition we want to put in your definition sections. Again, I'll make this available in Word. Sometimes we reference back to how the product is tested. They have to use test methods that were developed for the STA program. And sometimes there's an explanation of what the STA program in the spec documents. Again, I'll make these available to you. We don't need to go over them in detail. And this is something that Kelly, being a landscape, it's actually a trained recovering landscape architect, I guess is a way to put it. She reminds me that we need to have landscape architects actually be redundant. Put compost and mulch discussion in the specs and the verbiage packages, but also put as much detail as you can on the drawings so there can't be any mistake or claimed mistake by whoever is doing the project. Okay.
Ron?
Yes, ma'am.
I want to just clarify that a little bit. I'm not saying like you want to put the problem that could happen is if you say 2 inches in one place and 1 inch somewhere else, that you've got some conflicting things, but you always want to mention that you're at least doing the process, not create a situation where you have to change something in multiple places and potentially leave one out. Anyway, thanks.
Perfect. We talk again about, I like to have people specify the use of the product. Know that there is a new logo. If people have worked with me in the past, you'll see this STA logo. You're going to start seeing this square logo. The products are called Certified Compost. Now, remember this, a STA, a seal of testing assurance composter as a participant is a manufacturer of certified compost. So you may see different terminology for that. It essentially means the same thing. Remember that in the STA program, one of the reasons I like it is the bigger the composter you are, the more you produce, the more you have to test. You have to test through a certain series of specified labs that we watch over and make sure they're using the proper test methods. The STA composters are required to provide data for you guys and also provide you end use instructions on how to use the product. Remember that there are a lot of projects and a lot of public projects that require STA compost, so that has become a trend. Certainly Caltrans is one of them. These are the things we test for. I'm not going to talk about them in detail with not enough time in this session. We can do a session on that, one-on-one sessions at some point. And this is what the sheet, this is what the sheet looks like. I'll show you a little bit more detail of that. This is what we test for, and this is certain labs will have a summary sheet, and sometimes I like requiring that, or landscape architects can require getting that summary sheet sent to them, and there's more information that's provided, and I'll show you about that. But I did want to just show you that there were good specifications that already exist in the state. Both ReScape has a wonderful spec that already exists that you can glean from, as does Caltrans. And then, of course, I'm involved in projects that are funded by Stop Waste, and of course, San Jose, and I would also help you redevelop these, a lot of it based off of these specs, okay? And let's go for a little bit of a deeper dive. Now the real test is, who is diving right now? That is the question. Kelly already knows. If you get this right, your prize is going to be a cookie. I got nothing for you, but you know, I bet you know who it is. All right, so let me just show you the beauty of some of this test data. So here's a compost technical data sheet. In California, all the composters also get one for Caltrans. And I'll show you why they get one for Caltrans. In every state, the STA program works with departments of transportation. They recreate one of these specialized data sheets. And what we do is we help the states redevelop or develop their compost specs, and we develop them in the same pragmatic order as the compost technical data sheet. So if an engineer goes out to site, they get test data, it's very easy to look at the standard and compare it to the test sheet, okay? And that is one of the things that I try to do within LA Specs, is make sure that we put numbers in the spec and we put them in the order in which they're tested or illustrated. It's just faster to review, more helpful to people. We're trying to make it easier to use product and spec compost here. So here's this data sheet. I just want to show you again. And what I'm going to do, I'm going to talk about the 4 sections of this spreadsheet of the summary sheet. A couple longer than other ones, okay? But I just want to show you some things here, okay? All right, so here's a close-up where there's a whole bunch of information. Here's nutrient data going down the left-hand side of your page, dry weight basis, as is basis. As is basis is what's real when it comes to nutrient content, because it allows for moisture content to be dealt with or considered in that number. So what you can see here is, where's my moisture content number? Moisture content's about 43%, and you can see that 1.8 and 1.0 is about 60%. So I look at that. I look at the nutrient content. I compare the total nitrogen to the organic nitrogen. Look, almost total volume of nitrogen is in organic form, which means this would be a nice stable product typically that would be good for use for native species, right? Very low in ammonia. You can see ammonia has a burn factor to plants that's very low. That's a beautiful number. So that's something you look at. Electrical conductivity. Here it is, EC5. They talk about that's a 5-to-1 dilution ratio they use. 3.6, that's a really good number. And I just want you to mention here, millimoles per centimeter, that's the same as decisiemens per meter. That's the international number we should be using. That's probably the number we should be using on our specs, decisiemens per meter. There's soil pH. Bulk density, 39 pounds per cubic foot. I always joke the magic number is 37. If your compost is 37 pounds per cubic foot, that means it's 1,000 pounds per cubic yard. And we have a nice, easy to move material. What else? Organic matter. Organic matter is the inverse of ash. So whatever the ash number is, and ash in compost is remnants of soil, sand, silt, and clay, and actual certain nutrients that aren't burned off when you do the loss and ignition test for organic matter. And then there's some other tests people will throw in here, and like here's CN ratio, 16-to-1. You really kind of want to be below 20 if at all possible. Ag index, the higher this number, the better it is as a soil amendment. If it's a really low number, then it can have really a high, sodium and chloride ratio compared to NP and K. So kind of good salts versus bad salts. Okay, so this is just a little discussion of some of this stuff. It is important to know that in specifications, there are certain things that we always specify on as-is basis, certain things we specify on a dry weight basis, especially organic matter content. We always specify an organic matter on a dry weight basis. It's just what's been done forever. Okay? So what else? There's a heavy metals location or pollutant limits. The thing I want to show you here, I think that jumps off the page, is look at like some of these numbers. So there's 3 things like arsenic, cadmium, and lead, which are really the baddest, the worst things for living creatures. And if you notice that those things, the numbers, by the way, that lead number is wrong. That lead number, I don't know why it says 24 there. I'm leaving my desk to get my book because I feel saddened that I made a mistake. It is true. My kids have told me that I am not perfect. But oh no, this 300 number. Okay, this 300 number is correct. I thought it was a little bit off. But anyway, I wanted to show you these numbers are an order of magnitude lower than what's allowable, and lots of times even less than that, right? So the products are pretty darn clean, all right? Know that when you look at this number like iron, 12,000, 10,000 parts per million equals 1%. So that has a nice amount of iron in it. Iron is nice for greening effect in plants, right? So that's a good one. And here's the other thing that's very, very important to me. Stability and maturity. I've often been told by my wife that I am neither stable nor mature, and that's fine, and that is true. But here is something to look at. This is your CO2 evolution, your stability number. We want this to be a low number. Salts, stability, we want them to be low numbers typically. It's a very, very stable compost here. That will relate to very, very good plant growth. You can also see that your maturity test, and this is a measure, by the way, CO2 evolution is a measure of carbon stability, and maturity is a test of any phytotoxins in the material. So the standard is 80 and 80, and they have 80% seed emergence here, and 100, the plants actually outgrew the standard by 20%, which is beautiful. And of course, there's our pathogens we test for, just indicator organisms. The beauty of this is we knock out the pathogens, we're knocking out all those weed seeds. Physical contaminants, lots of times this information will not be perfect for landscape architects because, look, this is a less than number. It's less than 0.1. It could be 0, okay? But the point is, this product is very, very clean, as you can see here. That's how you look at that. And then a size distribution. Size distribution is an interesting one. Mostly landscape architects just want to know that it goes through a 9.5 millimeter or a 3/8 inch screen. And then 95 to 99% of it is going to be pretty darn fine, as you can see here. And here's one right here where almost all of it, well, actually all of it is under, it passes 3/8. This is a really nice fine product. Remember, this information, the full particle size distribution is really more important when you're speccing the product for specific, well, mulch uses, but also for erosion control uses, right? Also, I just wanted to show, finishing up here, I just want to show you that I like when there's interpretation data, but it is important that there's sometimes great concern that landscape architects get reading the interpretation data, because sometimes it's conflicting. And one of the reasons that is that compostability and maturity, when a compost is finished, there is no perfect test for that, that in the composting industry. We look at a variety of tests, and then we look at them together and we compare and contrast and understand whether it's done or not. And on this specific interpretation sheet, I don't like the way they talk about pH. And I've gotten several phone calls the last year talking about product that was called unstable because its pH was high, which I don't even think that should not be a parameter on here. So it's great to have this data. If you have any questions about it, you can give me a call, ask your composter, and let them walk you through some of that information. Okay, the interpretation. So finishing up here, getting ready for Q&A. Remember that there's a lot of compost available in the marketplace. There will be more coming. Compost is really a great and a really handy tool, great product for the use of the landscape industry and in the creation of healthy soils. It is really important for landscape architects to learn a little bit more. I have some cheating tools, that I can give you to learn more about compost, because specification is going to be required more and more. And I will make resources available to anybody who's interested in them. Basically, the short specs and the characterization, as well as the Word document of definitions to use if you want to redo your own standards, your own spec packages. You can even have me review them after the fact. And then you have the ability, and in the question and answers after we're all done here, when you answer your questions, you can tell us, you can tell me if you want me to contact you back, if you need some technical assistance on a project, or if you'd like have a lunch and learn or a one-on-one session within your office. So with that, I want to thank everybody for attending, and I'll open the thing up to questions. That would be managed by Kelly Schoonmaker, the Vanna White of composting.
I don't know about that. Hey, do you want to put your video back on, Ron? I'm going to do that.
Not really, but I will.
Well, I mean, it's more interesting than looking at.
All right.
Oh, I guess that's fine.
All right.
Okay, so
I left my heart.
We do have 4 questions already. I want to go to the quickest one first. Can we get a copy of today's presentation?
No.
Okay, there it is.
Of course you can. Of course you
Okay.
can.
Yeah, we can make a PDF available to people.
Absolutely.
Okay, so there's that one. And then to start at the top, could you please repeat the equation so to figure out like how much compost has been delivered? If you spec 1 inch of compost, how do you calculate that volume?
Right, 1 inch of anything is 134 cubic yards. Okay, so if you spec, if you
per acre, right?
Yeah, well, I'm sorry, per acre, correct.
You need that part, right?
Right.
Okay.
Duh. Thank you. My mistake. So yes. So yeah, the number to always have in mind is it's 134 cubic yards per inch, or 269 cubic yards per 2-inch application rates. And then there's typically somewhere between 40 and 50 yards in a truckload, depending on how heavy it is.
And the other one that's relevant for us with the WELO compliance is the other denominator that's relevant is the 1,000 square foot. So 4 cubic yards per 1,000 square feet is the WELO requirement, but an inch is more like 3.25, something like that, cubic yards per 1,000 square foot. So okay. There's that one.
Also know in the WELO spec, if you're trying to get to that 5 or 6% organic matter, you're probably going to need a little bit more than the 4 cubic yards per 1,000.
Okay, let's see. And then we have a question from Deborah Christman. What does it mean to have inverse of organic matter to ash? What would the numbers need to be?
There is no great requirement. You can have a really good compost. I'd like to see my compost at over 40%, between 40 and 50% organic matter, but 30 to 35 is very typical. And that should be 35 and above is pretty darn typical and would be a darn good compost.
Okay. And let's see, and next question. Could you briefly talk about the Solvita test and why they're not considered in the specs that you've presented? Right.
Well, so it's interesting too, because I put together a little write-up on that. I like the Solvita test to be used at composting facilities. Composters will use that sometimes. Let's say they have a windrow that's 1,000 feet long. It could be, 1,000 cubic yards in that windrow. And what they could do is pull a sample of that and do the Solvita test on site to see if the product appears to be finished. And if they do, then they take their samples and they send it off to an STA lab and they do their actual STA testing. Most people just prefer using a lab-based test because it's more reproducible. The Solvita test is a cool test, but you can pretty easily mess up, and people try to rush the test or they use it wrong, and then it doesn't help you in the field. So I don't have anything desperately against it. I just like to use it at a compost facility, and I rather use a lab-based method that's easier and it's more reproducible when I do specs.
Okay. Let's see, Deborah, I'm going to skip your next question to make sure everyone gets a chance to ask their question. What is the big difference? What are the big differences between compost for amending a soil compared to compost being used for mulch, 2 to 3 inches of mulch?
Right. So the great question. So the main difference is the amount of fine material or coarse material in the product. A lot of the specs, when they have a compost-based mulch, they typically max out the fines content sometimes at 25%. I think that's a little restrictive, but you really want to have 25-35% coarse material. It's all, remember, that's when you say doesn't sound like a lot, it's on a dry weight basis, and it's lighter than fine compost, so that will look like a very mulchy material. And that's the same kind of material, the kind of material that you would use for a mulch. A compost-based mulch would be almost the same product that you would use on an erosion control blown blanket.
Okay. We are right at 1 o'clock. And what we can do for the questions that we have not answered, well, if you have to jump off now, thank you very much. Please leave the meeting and fill out our evaluation. And hopefully, hopefully nothing has gone awry with this recording. And if you didn't get your question answered, hopefully you can stay on. If not, you can check it out on the recording. Okay, so, but I have time to stick around and answer the rest of the questions. And Ron, how are you? How's your time?
No, let's do it.
Okay. Okay. All right. Next question. Do you recommend compost for California native plants? This is like my favorite thing to talk about. As I understand, natives do not respond well to fertilizers and amendments, including compost. Can you please provide your thoughts on this? I'm going to mute myself.
Yeah, I could provide my thoughts, but the answer is that adding compost where native plants are grown is really a smart thing to do. And there is some great research done in the California region by University of California, showing that especially green waste composts are very good. The key aspect is not flooding the soil. Don't make too much readily available nitrogen available. And it's not to them, it's to the weeds that are competing with them. So sometimes we even use a coarser type of compost with some extra wood chips in it to actually cause a little nitrogen drag. It's actually pretty cool. The research shows that that can very easily be done. But we have found that yard trimmings compost that's really well stabilized with very little ammonia, little nitrate, can work quite well. And the key aspect here is the things that people forget is these natives are sometimes very difficult to establish, and they're expensive. So the organic matter will help them get established, and if it burns off and if you don't mulch over a long period of time and the organic matter starts to go, well then fine. But the key aspect here is getting it through establishment.
Okay, I want to add on to that a little bit.
Please.
And then when, as you mentioned, Ron, when we are given a project, typically the soil is not in great shape, and it's usually very low in organic matter. So you're not working in a native soil condition with the plants that are native to that place. So that soil structure improvement benefit that you talked about is really important for drainage. And when we say you can add compost at planting, we're not saying you need to add compost on the schedule that you would add it for like an agricultural row crop, right? It's different. It's correct. The natives don't need as much organic matter. And then even with the Marin Carbon Project, one of the pieces of research that they did was, because they were spreading compost on native grassland, or on grassland, was to look at the species composition and richness. And what they found was there was no change in the relative species abundance in the native plant population. They didn't get, like you have in previous research showing the application of fertilizer with an inorganic nitrogen, you do get an increase in weeds, but they haven't seen that in the research they've done on compost.
And also know that research has been done even I saw similar data to that in the south of Spain, similar arid conditions, same results.
Okay. Okay. I told you it was one of my favorite things. I couldn't stop myself. Let's see, is there a spec for amending plant holes versus a general area for sloped areas?
I'm not sure I understand that question.
Okay, Jeff, would you mind rephrasing that in the Q&A box? I'm wondering if it means more compost. And in the meantime, we'll go to the next question and then we'll go back to that one. How's that?
Okay.
Glenn Phillips is asking, how can we get your specifications, definitions, and application rates for different types of uses? We can make those available.
Absolutely. Right? We'll make them available after people answer the questionnaire.
After you fill out the evaluation. Why didn't we think of that?
Then
we'll make them available.
Isn't that really crappy?
We can do that.
Yeah.
All right. Well, anyway, we'll make them available. You just have to ask. Thank you.
Yeah. Got it. That's true.
Okay. Good idea, Ron. Next time. And then Annika asks, can Ron send the important parameters handout and talk about compost overs for bioretention mulch? Yes, we can send the handout. And I don't know if your questions were already answered in response to James's question, which was also about using screened overs for mulch. But do you have any specific things that you want to mention?
Well, I mean, there's a spec that I've been working on, and Kelly has been reviewing it for me, that I'm gonna have done in the next couple of weeks. But it really, the term arbor mulch is quite fascinating, because that's a term that's sometimes used. But these overs that are somewhat heavy and stringy, you never want to use the colored mulches that are very, very light. And what we find is these stringier and heavier, physically heavier materials, and ones that hold water better, actually are less floatable. And I worked last year and did trials in California with floatability based on some Australian research, and we found some really interesting things. And a nice compost overs product, which has some fines in it also, is quite effective. Spec will be available soon.
Yes, very soon. Let's see. So Deborah Christman asks, how do microorganisms survive 131 degrees, or do they appear after that peak? How does the compost get the microorganisms?
Well, so my grandparents grew up in Philadelphia, and they moved to Miami Beach, and they got more tolerant of heat, and they got tanner. So what basically happens in the early part of the system, where there's a lot of nitrogen, and a lot of food, it drives temperatures, and there are more bacterial species that like living in a high temperature, and they just persist. And as the food starts dropping, temperatures start dropping, and different microbes start moving in, ones that like that environment. So basically, the environment changes, and the ability for the microbes to populate the pile occur. And that's really the way it's done. I hope that answered the question.
If not, you can re-ask it. Okay, Jeff rephrased his question. How do you specify compost if only amending in the planting pit versus a general area, which may not be possible on a steep slope?
Right. So if on a steep slope, if we're gonna put, let's say, natives, we could go on a slope. It depends on how, I guess, how steep it is. But if you can get on there and actually dig out the planting hole, and blend the compost in there, and then you would basically blow compost on top as a mulch or for erosion control. I'm not really sure I'm answering your question.
You could try again, Jeff, if we haven't gotten it.
Really? You know what, Jeff? I got a better idea.
The compost itself, though, right? There's no difference in the compost itself. If you're talking about how to apply it in that execution component, that would be different, right?
Except if you're using compost in an erosion control setting, it'll be a coarser material.
Right. Right. Oh, I see what you're saying. Okay.
Yeah. But you know what, Jeff? You got my
There's
my phone number. Email. You send me a note, and I'll give you a call. We'll talk about it.
Okay. Okay, so Doug Anthony asks, it looks like the Bay Area has excess capacity to process food waste. How compostable are greenware, compostable containers, cups, and utensils? How are food waste source separated, and where do all these compostable containers get composted? Do you want me to talk about this one?
I think, yeah, go ahead, Kelly.
I mean, well, okay, so it depends on the composting system, how well things compost, and it depends on their processing. So, for example, but I would say that mostly, depending on the amount of the compostable, especially the plastic, and the plastic works a different way than the fibers do, right? And all the fiber is typically lined with like a ethylene liner, or not a degradable polymer, just classic plastic lining. And so that stuff sticks around even though the fiber will go away. With the compostable plastic, it depends on the size of the item and what the shape of the item is. So like those food scrap pail liners that you get, those mostly go away depending on, like, unless they're not like inundating the system. And but the cups and spoons and bowls, things that turn into a little sphere, as Ron mentioned, it's a surface area phenomenon. So what happens when you have a sphere is you have a really low, right, surface area to volume ratio, right?
Yeah, and I think.
So anyway, it goes slower. But.
Yeah, let me just finish up by saying that the big issue with these compostable materials right now is they don't always compost as fast as the composters want or need them to. So sometimes you have to lengthen the process.
And what's really difficult in California is that we have a hard time doing that because our composters don't have a lot of storage capacity for the most part. And that's because why? Because land is really expensive.
Yeah, big sites.
And this ASTM standard that you see on the label is for a 6-month process. And we do not really have a 6-month process. It's not, you can't find that really very easily in California.
It's also created for film plastic, not the other stuff, but.
Yeah. So the best thing to do is bring your own, use reusables. I know we've got this COVID thing, but there's also, well, let's just leave it there. Okay, thanks. Yep. Let's see. Gretchen Stransel-McCann asks, should compost not smell intensely when delivered to a site? And if it does, is this because it has not been allowed to go through the cooling process properly? I've noticed that the smelly compost provides high iron and then burns plants. Ideas? Okay,
so I think that the smelly compost sometimes smells like ammonia, and what probably burns or kills plants it could be the ammonia and not the iron. Iron is really chelated, it's really attached really well to organic matter. So I don't think that's what's causing it. I think it may be the ammonia. Sometimes there are aseptic type smells, which sometimes means it wasn't composted long enough or it's been too wet. Keep in mind that the one difficult thing in the Bay Area, you have some really good composters. Would I love some of those composters to compost for an extra month? Yeah, but they can't. It's really hard for them to do it. It just is really hard because they're big sites, but there's massive volumes of material. So it's hard to get product. You know, it used to be, we used to talk about compost smelling like the forest floor, and it's really hard sincerely hard to find a product that smells like the forest floor from a lot of the large commercial facilities. But the products are really, in most of those cases, really just fine for landscape related purposes. The big thing to watch for would be ammonia. But keep in mind that ammonia, if you blend it into fine soils, attaches to fine soils and should convert rather readily. But the things you look for burning are ammonia and high salts. Okay? And what was the first part of the question? Or not?
It was, hold on, I moved it. Oops.
Oh, smell. I talked about the smell.
Yeah, you talked about the smell. Yeah. Okay, so, and also, you know, if this rarely happens, but if you have a chance to buy it early and stockpile it and let it age a little bit longer.
Absolutely.
We, again, just like the composters are limited on space, we're limited on space everywhere here. So it's really difficult, but if you have that rare opportunity, it doesn't hurt to take it.
It's a great idea.
Thanks. I'm going to combine two questions. James is asking the suggested age of compost tests from labs that is acceptable. We typically state within 3 months of receiving the submittal. And Matt Moore is asking, can you address the highly variable, yes, can you address the highly variable nature of commercially produced compost, even from the same producer, from month to month? So I feel like that kind of gets toward a similar strategy to, you know what I'm saying?
So, except for the fact I can't take two questions at once, I'm an old man.
All right. Just start with the first.
What was the first question again?
Yeah. I see what you mean. The first
Yeah.
question was, what do you suggest for an age of compost test from the lab that's acceptable?
Right.
They state within 3 months from of
Right.
receiving the signal.
I think within 3 months is acceptable. I tell landscape architects, because of the STA program, even the smallest composters have to test every 3 months. So you should never get test data older than 3 months. Now, you could ask for multiple versions to look at just to see what the consistency is of the material. But yes, I think 3 months shouldn't be anything older than that. If you can do it sooner, it's great. But there is a situation here where the product that you typically buy is not the product you test very often, depending on how product is cycled. So it's a snapshot. Now, when it comes to variability, one thing that I should say right up front, people aren't going to like this, but I will say it, that it is important to understand that when you test soil and you look at mulch, earlier in the year, mulch is much prettier. When you compost certain mulches, then by the end of spring, sometimes the mulches aren't quite as composted, so they look a little bit different because of time. So this is not an unheard of thing. We would like the product to be as consistent as possible, but you sometimes will see variability. Really, the variability should not be big. It really should, and I can't give you a number from that. Matt, we could talk about that later on. But sometimes when people are basically trying to fill orders and they take young product, then sometimes the young product, while still may be good enough to use, may have different numbers, different characteristics.
So I guess what I was trying to paint you into a corner just saying is when you ask for the test data, if you ask for those multiple tests, that can help you identify both figure out what the variability is really like in a particular facility over time. Is it consistent? How consistent it is? And also that would help too with looking at the suggested age of those compost tests. So even if you got one that was almost, that was 4 months old, if they've looked like that for the last 2 years, you're probably going to get the same stuff with the stuff you get, because you're never ever going to be able to test the actual compost that you're putting on the ground.
Right, and it is important to know that some facilities have much better success with keeping materials very consistent. It's variable by producer.
Okay. Here's a question. If we use compost, from Holly Selvig, if we use compost, should we also specify fertilizers?
Yeah, I got to tell you, with a lot of plant materials, I'm not sure that I want to see fertilizer packages. I'd rather see you have the product in the ground for a year, the plant in the ground for a year, then come back. There's a lot of nutrients, especially nitrogen and phosphorus, that will cycle out the first 2 to 3 years, actually. Turf, yes, you would need more high nutrient requiring plants, but I think an awful lot of plant species, we don't need it. I truly believe that.
Right. Especially given the direction the state has gone with the water efficient landscape ordinance, requiring more drought tolerant California native and Mediterranean plants that need less organic matter anyway, and less nutrient, and have a lower nutrient demand.
Yep, totally agree.
All right, thank you. And this is from Nyoka. What is the classification of arbor mulch? I'm not sure I understand what that means. Is she still here? She's still here, so she could maybe interpret that. And then she and then she asked for the handout, or the arbor mulch being placed over for the biotreatment mix, the study on the non-floating mulch. And then she asked for that. So Nyoka, can you rephrase that question?
And we can always talk about it offline too, but remember the material, arbor mulch is a made-up name. I don't know, but it's found its way into a lot of the specs for bioretention. And
arbor mulch could be any mulch. Well, I think we use it to mean mulch from tree trimmings.
We do, We do. And keep in mind that if you have something that's been composted, there's typically, there's a water is allowed to kind of get into the wood, which makes it heavier. And then it's stringier. And then there's going to be some fine particles that add to the weight. And it's the combination of those things seem to help. Remember this, all these mulches can be floatable. Having a floatable mulch is called a rock. But what we're trying to do is to design something that floats less, or that may float a little bit, but doesn't break apart and run, that comes back down again. That makes sense.
Mm-hmm. And I would like to point out that even gravel moves. You know, when you get those high flows, it'll migrate a lot too, which we've all seen. Okay, that is it for the questions. So I want to thank everyone for sticking around, and the last of you who made it. And if you have any further questions, you can, of course, email Ron directly or me, if that helps.
And it's Ron at alexassociates.net.
You have a different email address on the slides. Will that one work too? alexassociates@earthlink.net?
It will, but it's not supposed to be there.
Oh dear. So anyway, well, we can fix that, and
it's not a big deal. It'll get through to me.
Yeah,
and hopefully. I'm sorry.
I was just going to say, we're sending out a follow-up email tomorrow, and I can put your preferred email address in that.
We'll do that. I will do that.
Well, thanks again, everyone, and please fill out our evaluation and let us know. And then one of the questions in there, I should let you know, is if you are interested in this kind of information for your organization, your firm, your company, your city, whatever, you can indicate that there, and there's a variety of, or you need technical assistance, or you want to try to do a tour of a composting facility, let us know, and we'll see how we can help.
And just a final thank you to the sponsors, and especially to Kelly for being fantastic as a host. And I look forward to getting back out to the sunny state of California soon.
Sure.